Welcome to another episode of the Virtual Reality Reconstructionist, the show where we peel back the layers of technology to uncover the stories, the breakthroughs, and the bits of magic that shape our digital world. Today completes our second part of a two-part series of facial recognition technology and virtual reality. You know, it's fascinating to think that we've gone from marveling at facial recognition in spy movies to unlocking phones at just a glance. And VR, well, it's like stepping into another universe from the comfort of our living room. But how did we get here? What stories are behind these technologies, and where do it's taking us next? Let's get started and find out. We've got a lot to cover. Once considered a thing of science fiction, biometric face recognition is quickly becoming an integrated part of people's everyday life. Several major industries have benefited from the rapid advancements that have been made in facial recognition technology over the past 60 years, and these include law enforcement, border control, retail, mobile technology, and banking with finance. The earliest pioneers of facial recognition were Woody Bledsoe, Helen Chan Wolf, and Charles Bison. In 1964 and 65, Bledsoe, along with Wolf and Bison, began working using computers to recognize human faces. Due to the funding of the project originating from an unnamed intelligence agency, much of their work is unpublished. However, it was later revealed that the initial work involved the manual markings of various landmarks on the face, such as eye, centers, mouth, etc. These were then mathematically rotated by the computer to compensate for pose variations. The distance between landmarks were also automatically composed to compare between images and determine identity. These earliest steps of facial recognition by Bledsoe, Wolf, and Bison were severely hampered by the technology of the era, but it remains an important first step of providing the facial recognition was a viable biometric. Carrying from the initial work of Bledsoe, the baton was picked up in the 1970s by Goldstein, Harman, and Lesk, who extended the work to include 21 specific subject markers, including hair color and lip thickness, in order to automate the recognition. While the accuracy advanced, the measurements and locations still needed to be manually computed, which provided to be extremely labor-intensive, yet still represents an advancement in Bledsoe's RAND table tablet technology. It wasn't until the late 1980s that we saw further progress with the development of facial recognition software as a viable biometric business. In 1988, Surovic and Kirby began applying linear algebra to the problem of facial recognition. A system that came to be known as EigenFace showed that featured analysis on the collection of facial images could be set to basic features. They were also able to show that less than 100 values were required in order to accurately code a normalized facial image. In 1991, Turk and Pentland carried on the work of Surovic and Kirby by discovering how to detect faces within an image, which led to the earliest instances of automatic facial recognition. This significant breakthrough was hindered by technology and environmental factors. However, it paved the way of future development in facial recognition technology. The Defense Advanced Research Project Agency, DARPA, DARPA, and the National Institute of Standards and Technology, NIST, rolled out the Facial Recognition Technology Program, FERET, FERET, in the early 1990s in order to encourage the commercial facial recognition market. The project involved creating a database of facial images, including the test set where 2,413 still facial images represented 856 people. The hope was that a large database of test images for facial recognition would inspire innovation and may result in more powerful facial recognition technology. The National Institute of Standard and Technology began face recognition vendor testing in early 2000s, building on FERET, FRVTs, that's FERET and FRVTs, were designed to provide independent government evaluations of facial recognition systems that were commercially available, as well as prototype technologies. These evaluations were designed to provide law enforcement agencies and the U.S. government with the information necessary to determine the best ways to deploy facial recognition technology. Launched in 2006, the primary goal of the Facial Recognition Grand Challenge was to promote the advancement of face recognition technology designed to support existing facial recognition efforts in the U.S. government. The FRGC evaluated the latest facial recognition algorithms available in high-resolution face images. 3D face scans and iris images were used in the test. The results indicated that the new algorithms were 10 times more accurate than the face recognition algorithms in 2002 and 100 times more than those in 1995, showing the advancement in facial recognition technology over the past decade. Back in 2010, Facebook began implementing facial recognition functionality that helped identify people whose faces may feature in the photos that Facebook users updated daily. The feature was instantly controversial in the news media and sparking a slew of privacy-related articles. However, Facebook, used by and large, did not seem to mind, having no apparent negative impact on the website's usage or popularity. More than 350 million photos are uploaded and tagged using facial recognition each day. Facial recognition technology advances rapidly from 2010 onward to September 12, 2017, was another significant breakthrough for the integration of facial recognition into our day-to-day lives. This was the date that Apple launched the iPhone X. The first iPhone users could unlock with Face ID, Apple's marketing term for facial recognition. Border controls, airlines, airports, transport hubs, stadiums, mega events, concerts, and conferences. Biometrics playing a growing role not only in the real-time policing and security of increasingly crowded areas and the valued venues worldwide, but also it ensured a smooth, enjoyable experience for the citizens who visited them. As a longtime committed pioneer of biometric research and solutions, NEC has developed multimodal technologies including face, iris, and voice recognition, finger and palm print identification, and ear acoustic authentication, and supplemented them with AI and data analytics to enhance situational awareness and facilitate effective real-time and post-event action in both law enforcement and consumer-oriented spheres. Face recognition can often prove one of the best biometrics because images can be taken without touching or interacting with the individual being identified, and those images are recorded and instantly checked against existing databases. NEC's face recognition offers high-performance, scalable solutions for the most demandable real-time and post-event requirements. With face recognition, search, identification, and verification functions all on a single platform, it can be easily integrated into existing security systems to extract faces in real time, matching them against an existing database or watch list and produce real-time alerts to help reduce public safety risk. With the ability to process and analyze multiple camera feeds and the thousands of faces per minute, NEC's powerful face recognition is able to address the largest and most difficult security challenges and unparalleled efficiency, sensitivity, and perception. In response to booming demand for varied biometrics, NEC has expanded its traditional range of facial recognition applications from law enforcement and security divisions to new areas and now boast more than 1,000 active systems in over 70 countries and regions spanning police, immigration control agencies, nationwide ID, banking, entertainment, stadium, conference venues, and many more. Right now, many of the facial recognition technologies solutions are blazing a trail for the first time use in new areas and venues worldwide, such as end-to-end airport travel experiences in the U.S., mega event security in Japan, and EU summit security in Europe. In 2019, NEC was named the Frost & Sullivan Asian Pacific Biometrics Company of the Year in recognition of its leading position in the industry and foresight in innovating and developing the future. Innovative advancements in facial recognition technology have seamlessly integrated into various sectors, revolutionizing how we authenticate identities and ensure security in an ever-increasing digital world. Now let's shift gears. Let's explore the immersive realm of virtual reality, VR. Virtual reality simulations come in three primary categories: non-immersive, semi-immersive, and fully immersive. These classifications delineate the depth of immersion user experiences with virtual environments. Each category represents a distinct approach to virtual reality, providing users with varying degrees of immersion and interaction. First, let's address non-immersive simulations. At the foundational level of VR experiences, non-immersive simulations offer users a glimpse into virtual environments through conventional display screens such as computer monitors or smartphones. These simulations provide a rudimentary form of interaction, allowing users to navigate digital spaces using traditional input devices like keyboards, mice, and touchscreen gestures. While lacking the depth of immersion found in other categories, non-immersive simulations serve as a valuable tool for educational, architectural visualization, and basic training purposes. Non-immersive VR simulations have found widespread application in architectural design and urban planning. Architects utilizing non-immersive VR to create virtual models of buildings and urban landscapes allows clients to explore proposed designs before construction begins. By immersing clients in digital representations of architectural projects, non-immersive VR facilitates collaborative decision-making and enables the stakeholders to visualize spatial relationships and design concepts more effectively. Moreover, non-immersive VR simulations play a crucial role in the educational setting, providing students with immersive learning experiences across various disciplines. From virtual museums, tours to historical reenactments, non-immersive VR enhancements traditionally pedagogical methods by offering students engaging and immersive learning environments. Additionally, non-immersive VR simulations are utilized in basic training scenarios such as fire safety drills or workplace hazard situations to familiarize individuals with emergency procedures in a virtual setting. So now let's discuss the semi-immersive simulations next. Moving along the spectrum of VR experiences, we encounter semi-immersive simulations, which often uses the heightened level of immersive compared to non-immersive experiences. In semi-immersive VR, users wear head-mounted displays, or HMDs, to enter virtual environments, which cover a portion of the user's field of view, creating a sense of presence within the digital world. Additionally, semi-immersive simulations may incorporate additional sensory feedback, such as spatial, audio, and haptic feedback devices, to enhance the immersive experience. Semi-immersive VR simulations find extensive applications in healthcare, particularly in medical training and patient education. Medical professionals utilizing semi-immersive VR environments to stimulate surgical procedures, allowing trainees to practice complex techniques in a risk-free setting. By replicating realistic surgical scenarios with high-fidelity visual and tactical feedback, semi-immersive VR simulations help medical professionals develop critical skills and improve patient outcomes. Semi-immersive VR simulations are employed in psychological therapy and rehabilitation programs to treat various mental health conditions and physical disabilities. Therapists using semi-immersive VR environments to expose patients to controlled stimuli, such as phobias or traumatic experiences, in a safe and controlled environment. By immersing patients in virtual scenarios that replicate real-world simulations, Semi-immersive VR therapy facilitates exposure-based treatments and promotes emotional healing and cognitive restructuring. You will hear more about semi-immersive or augmented reality in our segment with Avrio Analytics. Avrio is using AR to train law enforcement in de-escalation and active shooter events. For now, let's talk about fully immersive simulations. At the pinnacle of the VR spectrum are fully immersive simulations, which offer users the highest level of immersion and sensory fidelity. In fully immersive VR, users are completely immersed in virtual environments through advanced HMDs equipped with motion tracking technology, enabling them to interact with digital objects and environments in a naturalistic manner. Fully immersive simulations aim to replicate real-world experiences with a high degree of accuracy, providing users with immersive and engaging virtual experiences. Fully immersive VR simulations have diverse applications across industries, including gaming, entertainment, and simulation-based training. In the gaming industry, fully based VR experiences transport players into a fantastical world and immersive storytelling event, allowing them to interact with virtual environments and characters in unprecedented ways. From immersive role-playing games to adrenaline-pumping action adventures, fully immersive VR gaming offers players unparalleled levels of immersion and interactivity. Moreover, fully immersive VR simulations are utilized in aerospace, engineering, and defense industries for training purposes, enabling engineers and pilots to conduct virtual flight tests and spacecraft design evaluations in a simulated environment. By simulating complex scenarios in real-world conditions, fully immersive VR training simulations help professionals develop critical skills, expertise in a safe and controlled setting. In an era where facial recognition technology is becoming increasingly pervasive, it's imperative to examine the impacts in security and privacy. As this technology evolves, striking a balance between its benefits and ethical considerations is crucial. Let's delve into the complexities of facial recognition technology and its implications for security in our society. Facial recognition technology has rapidly evolved in recent years, recognizing various aspects of our lives, from unlocking smartphones to enhancing security at airports and border controls. However, as the technology becomes more prevalent, it also raises important questions on privacy, ethics, and security. At its core, facial recognition is a biometric technology that identifies and verifies individuals based on their unique facial features. The process involves capturing an image or video of a person's face, extracting key facial landmarks, and comparing them to a database with known faces. This comparison is made possible by complex algorithms that analyze various facial attributes such as the distance between the eyes, the shape of the nose, and the contours of the jawline. One of the key techniques used in facial recognition is feature extraction, which involves isolating distinct facial features from an image, such as the eyes, nose, and mouth. By focusing on these specific features, the algorithm can create a unique facial signature for each individual, which can be compared to other signatures in the database. Facial recognition technology offers numerous benefits, including enhancing security, convenience, and efficiency. In law enforcement, facial recognition has been used to identify suspects and locate missing persons by comparing images from surveillance cameras to databases of known individuals. Additionally, in the healthcare industry, facial recognition has been employed to detect certain medical conditions by analyzing subtle changes in facial features over time. However, the widespread adoption of facial recognition also raises concern about privacy and security. The collection and storage of facial data have raised ethical questions regarding consent and potential misuse. There are also concerns about the accuracy of facial recognition systems, particularly when it comes to handling variations of facial appearance, such as changes in light conditions, facial expressions, and aging. To address these concerns, regulations and guidelines are being developed to ensure the responsible use of facial recognition technology and protect individuals' privacy rights. It is essential for organizations implementing facial recognition systems to adhere to strict data protection regulations, obtain informed consent from users before capturing and storing their facial data, and ensuring transparent use policies. Efforts are underway to improve the accuracy and reliability of facial recognition systems while minimizing the risk of bias and discrimination. Research and development in the field are focused on developing more robust algorithms that can handle variations in facial appearance and mitigate potential bias. That was a lot of information, wasn't it? How exciting to be living in a time where we can leverage technology in more ways that we can imagine as we explore today. In today's episode, we've navigated the complex and intriguing worlds of facial recognition and virtual reality. From the early beginnings to the modern incarnations, these technologies are not only reshaping our digital interactions, but also raising important questions about privacy, ethics, and the future of technology. Thank you for joining me on the Virtual Reality Reconstructionist, where we unpack the past, present, and future of these fascinating technological advancements. Until next time, stay safe and stay curious.